Hello, everybody, and welcome to this short part two that I've recorded as an extra for the session that I did on October the 14th for the annular full moon a few days ago. I decided to re-record the actual pattern drawing process because a few days ago when I did it, the light wasn't so good. So I'm going to record it again now with more light. And here I am in a different place, actually. I'm in my mother's art studio in London. So I shall change over to my drawing camera. So you'll remember we were using Albrecht Dürer's particular process for dividing a circle up into 11. Now I'll describe what he said again. This is the quote from him. To construct an 11-sided figure by means of a compass, I take a quarter of a circle's diameter, extend it by 1/8 of its length, and use this for the construction of the 11-sided figure. Now, using the inch markings on the ruler, you need to get a 4-inch measurement onto your compasses. Now we want to make sure that where we place the point of our compasses is right in the middle of the page, between the top and the bottom. So as you can see, I've got A3 paper in landscape orientation. Now we aren't so concerned about going off the page on the sides, so you can probably just judge the middle between these two sides with your own eye. Now, before I draw the complete circle, I'm going to put the point of my compasses into the middle and just make a single mark to one side, like so. And the reason why I'm doing that is just so that I can check if my distance is actually 4 inches. Yeah, so that looks good. So I'm going to go with that and draw my circle. Now this circle, radius of 4 inches, so obviously diameter of 8 inches. Right, so back to what Dürer said about the way in which he divides the circle up into 11. He said that he takes a quarter of the diameter. So here we have the diameter, 2 inches is a quarter, 2, 4, 6, 8. And having taken that quarter of the diameter, he then increases it by 1/8 of its length. Now, as you can see, the 2 inches, which makes that 1/4 of the diameter, is made up of 8 quarter inches. 1, 2, 3, 4, 5, 6, 7, 8. So he increases it by 1/8. So 1/4 inch more. So it's 2 1/4 inches is what we need. Now, I might as well show you the mathematics of this because they are of a certain amount of interest. And if you find maths difficult, this might actually be of use because you can actually see what's going on, as it were. All right, I'll get my calculator on. Now, when you divide a circle up into 11, the relationship of the radius to the edge length of an 11-sided shape is this. If the radius is 1, then the edge length is this. 0.563465. We'll leave it at that. Now this, I assume, is probably worked out through trigonometry. I've got a list with all of the radius to edge length of all the various polygons. And this is what it says for 11. Now, if we look arithmetically at what's going on, it's quite interesting. So if we're talking about that as being a radius, that would be this measurement here. And of course, it's half a radius is actually what we've used. We've used 2 inches to begin with. So when he says about dividing the quarter over diameter up into 8. So if we take 1 and we divide it by 2 first, obviously we get 0.5. So that is what 2 inches relates to, 0.5, half of a radius, effectively. Now, if we divide this by 8, we get that. So that is 1/8. So we need to add that to 0.5. So, if we get that 0.5 back again, so I'm going to add this plus 0.5, and there we have it. So this is what Dürer uses as his division of the circle up into 11. So you can see how very similar it is. 1 to 0.5625. So it's very slightly smaller than the actual complete or correct 1/11 of a circle. Now, this technique is one that's used a lot in, I've shown it being used a lot in my research about the design of Wells Cathedral, whereby a lot of the, I suppose what you could say, incommensurable geometric measurements that there are rationalized into very, very similar rational units of measure. And this is really the same thing going on with this particular instance of the division of the circle into 11. Now, I'll probably say more about that rationalizing of irrational measure that's in my cathedral research in future sessions, but let's just carry on from here now with this one. So I've increased from 2 inches to 2¼ inches. So that's that 1/8 of 2 inches is the increase. Now, this is what I'm going to use to divide the circle up into 11. Now, I'm going to go into the top like so. Now, the compasses do go off the top of the page, so don't worry about that, because it's actually the intersections of these circles that we're about to draw. That's what we're going to be needing for dividing the circle up into 22, which is what we're going to do after we've divided up into 11. Now, this intersection here, this is what we need. This is what needs to be on the paper. So as long as that's on the paper, then it doesn't matter that this upper circle has gone off. Now, because of what we would generally call accumulated error, I'm actually going to just go halfway around with these circles, and then I'm going to start from the top again and go this way around. And again, 2 circles at the bottom, one of which I've just drawn. They will go off the page, but again, as long as you have the intersections of the circles that we're drawing here, that's really what's necessary. So as you can see, I've gone back up to here now to begin the journey around in this direction. Right, now there you go. That's this has worked out quite well, this one. Because of this being ever so slightly smaller than the actual 1/11 of the circle, I have very, very slightly overcompensated, sort of compensated for that by putting the point of my compasses ever so slightly, I mean, half of a pencil width ahead of where it would be. And that's allowed this to seal up quite well. Doesn't always work out quite so well, but this one seems to have. Now this intersection here at the bottom, just on the page, that's what we need as well. So this is why I was keen that you started from very precisely from the center of the page. So here is our division of the circle into 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now to divide the circle up into 22, which is really what I was talking about in the session the other day, if you look at that particular video, if you haven't already seen it, that's where I give a slideshow and I talk about how 22 and 7, that pi relationship, again, a rational approximation of pi, I describe how that shows itself in the solar cycle and also Mercury's orbital cycle. Hence our focus on 22. Now, very simply, because these here are vesicas, we can just draw a line through the middle of the vesica, and that will, of course, bisect our 1/11th. Now, it's worth lining your ruler up with the center of the whole diagram, as I have done here. We only really need the line going through like that. I mean, to be honest, we only actually need it going through here, but it's quite nice to sort of put the whole line through the vesica. And so that gives us the 22-fold division. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now, having done that, the next thing that I'm going to do is to put pinprick holes through here, through these 22 points, and then I'll be able to turn the paper over and draw a 22-fold star on the other side. Now you should already have pinprick holes from the initial 11-fold division of the circle. So some of those are just being enlarged a bit. That's what I'm doing here. Right, I doubt you can see my 22 pinprick holes here. So I'm just going to put a little ring around this one at the top and this one at the bottom, and that will help us to orientate ourselves. Now, in the other recording that I did, the part 1 recording that I did at the time of the full moon a few days ago, I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I counted 11, I get all the way around and I'd just be drawing a diameter from top to bottom. So I just counted 10, and each time I draw a line in this star, I'm going to be counting 10. So that was 1, 2. I don't count the one that I'm beginning from. That's just my beginning point. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I count again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, because I'm used to doing this, I can sort of, I know visually which one I'm going to go to each time. So I'm not counting, but I am essentially following that pattern of counting 10 forwards each time. Now, what will end up happening here is that we'll draw an 11 pointed star, which I'm just about to finish. And then that will be joined by another 11 pointed star that uses the points in between. And that will give us one of what are actually 9 different 11 pointed stars, or 22 pointed stars. Sorry. And then I'll just briefly talk a little bit more about that, because one of the things that I'll go into in a later session is the pattern that exists in relation to how many polygon stars you can get from each particular division of the circle, because there is a pattern. It's quite a nice pattern that naturally occurs. Of course, number is all about patterns. Now that is, I suppose you could say, the most stellated of the 22 pointed stars. There's 9 of them, and the reason why there's 9 of them is because, well, if we say that, well, if we went from this point to the next door point and we kept on going to each new next door point, we'd get a 22-fold polygon. But to get a star, the most basic simple one is to skip the first point and go to the second. And what we'd end up with is an 11-fold polygon, which would be overlapped by another 11-fold polygon beginning from here and going to here. So by skipping one and going to the second one, that is the first star that we get. Another star that we can get is if we skip 2 and go to the third, or if we go to this one first from here, that'd be another different star, or from this one to this one, and so on. So we have all these different possibilities, and you can draw all of these 22 pointed stars once you've done this one. I just skipped 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that gives us the most stellated star you can get. But if you count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, that would be the most simplest one if we went from here to here and so on. So that's why there are 9 different 22 pointed stars that you can have. Right, okay, thanks for looking at this this session. I'm going to be back on Saturday the 28th of October, which is a full moon and a partial lunar eclipse, and we'll do some more drawing, and I'll show a few more slides at that particular session. So do come along to that, and I hope you've enjoyed drawing in this session. See you again. Bye.